here. The implementation of the polynomial regression is important regression category or flavor where we need to do something from the non-linear way. So multiple linear regression and linear regression both are follow the concept about the linearity. So when talking about the non-linearity, what we need to do, we need to understand the important part, that is we have over here the polynomial regression. From the polynomial regression you can understand, you can read out to some point over here. The polynomial regression is a regression algorithm that models the relationship between the dependent and independent variable with the degree, that is the nth degree polynomial. So what we need to pass over here, uh, we need to use our model in form of the degree mechanism. So polynomial regression equation you can find like over here. So now please keep in mind the some important words here. Here b0, that is a first independent variable, b1 that is a second independent variable, but see now keep in mind b0 is not a independent variable. This is an intercept. Okay, so this is the intercept point, and b1 would be the our coefficient of the first value of the x, that is the x1 here, and here we have to pass some degree. So 1 2 3 all these part after the this x1 that defines the degree. So you can see that here we have the x1 and it has some power, that is a 1, so no need to write over here, but here we can say the x12. So what is x12? X12 means x1 is the name of the independent variable. Here we are have only one independent variable and one dependent variable, but independent variable have the power, and b2 is the coefficient of the x1 variable and followed by the, now see, it contains x1 variable will contain some power, that is 2, and same thing 3 power, and so we have the n power. So that's why we can say the polynomial regression is a regression mechanism or algorithm which defines the relationship between the independent variable and dependent variable followed by the nth number of the polynomial degree. So this is my point. Okay, no need to it is not possible to write the power over here, so that's why I just put it the like over here, but I'm explaining the thing. Last the digit, that is a 3 2 1, 1 is optional. So it defines the degree or it defines the power of the x1 variable. So you can see, but question comes in our mind, what is the need of the polynomial regression in the machine learning? So you can say if we apply the linear model, the linear data set is sufficient, and it provide us a good result, as we have seen the simple linear regression so far we have discussed. But when talking about the something that is required to provide the polynomial nature, so at the time we need to use the polynomial regression. So you can read out the so many points over here, that is the, we can say that due to now I'm just reading over here. So the polynomial regression, the polynomial data model provide the good result, as we have seen and we have noted down to the previous examples in the simple linear regression. But what we have observed here, but if we apply the same model without any modification on non-linear data set, now data set should be in the non-linear way. So suppose we have the data set in the non-linear way, then it will produce the drastic output, so we will not get the good prediction. So at the time the polynomial regression play important role. So due to this point, we have to update our cost function. We need to increase the cost function, and that that defines the error rate will be high and accuracy will be decreased. So we can't lose the cost function, or we can say we will not losing our some information. And if you're doing some, so what we are doing, we are increasing the rate of the error rate, we are increasing the error rate high, and we are not getting the accuracy good way. So at that time the polynomial regression play important role. And for such cases the some data points are arranged in the non-linear fashion. I will show you by the image, then you can understand. And we need the polynomial regression model, and at that time we can say we can understand it is in a better way to using the below comparison diagram of the linear data set and non-linear data set. Now if I'm saying below, so you can see this image right now. Now let me know this image is visible to all right now.
Yes, yes, sir.
Yes. So what you have been observed over here, just let me clear this point. In a simple linear model, if your line is fit to this point or this point, but your actual data points are dotted, designed or just pointed into the or scattered onto the here, but it has the use point of the error. We can say the actual points are dotted plotted over here, but actual the predicted information is coming over here. So what we are observing, we are observing something here, that we have the number of the error in the high amount, and that we can't manage. So at the time the polynomial regression will touch the close to the all point, or we can say the polynomial regression will help the or fit the line close to the all the points. So we can say here we will not follow the straight line equation, here we will use the some polynomial equations based concept. So that's why we can say our line will fit the, or our model will fit to the close to the all the data points followed by the polynomial equations. This is my point. Now, is it clear to right now why polynomial model is required instead of the simple linear model, when we are not fitting the model close to the data point, and data model are providing the data points are providing the difference between the, or just having the difference between the actual data points. So we will have the huge amount of error. So to avoid or to minimize the error, polynomial regression play important role at that time. This is my point. Now, is it clear to all right now? Is it clear? The difference between the linear model and polynomial model.
Yes, sir.
Okay, so after understanding these points, I'm just putting some over here. See, simple equation we have the in the linear regression, y equal to mx plus c. Okay, so that is the intercept point and coefficient we can say. So b0 will be the intercept point, and b1 will be the slope, and x1 will be the our x value. Here we have the independent variable one and one independent variable, dependent variable. The multiple linear regression, we have the x1, x2, xn. What we have? We have the multiple dependent independent variable, but y would be the dependent variable. So this is the point you need to keep in mind. Y always would be the dependent variable, and x1, x2, xn. So all these are would be the independent variable, and b1, b2, bn, all these are the coefficient of the respectively x1 values. Okay, x1, x2, and so on so values. And b0 would be the intercept point that could be identified by the c in the y equal to mx plus c, as we have seen this important point. But even talking about the polynomial linear regression, what we have been observed so far after understanding the image or diagram, y equal to b0 plus b1 x1. So here what we are observing here, we have the one independent variable. So the point you need to keep in mind, one independent variable that is identified by the x1 only. But this x1 variable will contain the its degree starting from the 1 2 through up to the n, as according to the number of the data point we have. So b0 would be of course a c, that is the intercept point, and we're talking about the b1 x1. So b1 would be the coefficient of the x1 independent variable, and if we're talking about the b2 x2 x1, so x1 will be the independent variable and which has a coefficient b2 but followed by the degree 2. And same thing we have the bn. So bn is the coefficient of the x1 independent variable followed by the nth degree. So this is the what? This is the polynomial equations we have, and here we have the only one independent variable. So what we have? We have the polynomial linear regression. It means there would be only the one independent variable, there would be only the one independent variable. But by this equations, by the polynomial equations, you can make your or you can fit the model close to all the data points, so error can be minimized automatically. And this is the beauty of the polynomial regression. That's why I'm speaking over here. So now tell me, is it clear to right now the difference between the polynomial and linear model? Yes, please tell me. Any doubt you have, then you can ask me right now. So I have shared the my equations of the three different models, and here we have the image. Then you have any doubt, then you can ask me right now. Yes, student, please tell me. Any doubt? Any doubt in the theoretical part of the this polynomial regressions? Just please tell me.
No, sir.
Okay, whenever you have any doubt, then you can ask me anytime. But you don't have, just let it me know. Please be genuine, and while speaking anything over here. Now, same thing. What I'm just going to here. See, I'm importing a library, or all the important library is required. So importing the library means I'm importing the NumPy library. I'm importing the Matplotlib library for plotting the my images. For show to my proof, is it polynomial is happening over here or not? And pandas library for of course for the data frame or data set representation. So after importing library, you can import your data set directly without your physical data set into your system. You can directly import the data set from the internet as well. So that would be the path. So you in the same method we have over here, pd.readcsv. Readcsv is the name of the method. But instead of the passing the .csv file, you can pass the URL of the your available data set directly, so you can easily access like over here. So now I have this data set, the syntax, but I have downloaded this data set into my computer, and I have few minutes ago I have shared such data set on the MS Team, so you can easily find out such a data set over the MS Team as well. Now is it visible to all? Did you got the positional salary data set? Yes, please tell me. Did you got? Yes, please tell me. Did you got the this information?
Yes, sir, got
Position.
it.
Yeah, good, good.
Sorry.
Okay. Now, same thing as we have done in the linear regression, we will do what we were doing. We are reading the data set. After reading the data set, we will print the X and Y. Okay, so you can print. So I'm just printing the data set over here. So I'm not opening the .csv file directly. I'm just directly showing the what are the value which is contained by the position salary data set, and what are the features of it we can easily find out. So it has the various features. Those are the position, level, and salary. Suppose as a after joining a company, I becomes a manager, I become a business analyst, junior consultant, and different kinds of positions are available. So according to the position, my salary is being increasing day by day or maybe year by year, of course. So and that is defined by the level 1, 2, 3, and so and so, because I belong to the first level. So as an initiator, you are joining any company, could be the form of the programmer, could be the software developer, and after the few years you will be get a chance to be promote. So after being promotion, or after being promoted, uh, you will be the part of the system analyst, or you can be a system analyst post. So system analyst post is higher than the software programmer, and after the few years on spending the more year in the same company, you may become the COE. So definitely after being a COE, you will have the good salary. So salary will be increased by the based on your position. So what is the point you are noting down over here? In the position salary data set, salary is a dependent variable, and that is depend on your position. Am I right now? So position is what? Position is a independent variable, dependent variable. So tell me, what is the independent variable? What is the dependent variable? Position and level both are the independent variable. Okay, and salary is a dependent variable. Is it clear to right now? Is it clear?
Yes, sir.
Yes. Any doubt here? Please tell me. Any doubt do you have? Then please you can ask me right now. Same thing we are doing as we have done this yesterday. We are not doing anything new. We are just following the something into the polynomial way. What we are doing, we are just modifying our thing into the polynomial way, followed by the linear regression. Nothing else specially. Linear regression is the basic algorithm, and that algorithm we are using the multiple independent variables. So we are following the multiple linear regression, but we have the our information in form of the straight line representative, or we are not fitting the model followed by the straight line equation. We are fitting the model followed by the polynomial way. So what we have the polynomial linear regression. Okay, so this is my point. Now, yes, tell me any doubt do you have? Please, you have any doubt, then you can ask me right now. Please tell me, do you have any doubt? Yes, then tell me, yes, do you have any doubt?
No, sir.
No, sir.
Okay, so see, so in the what we have done in the what we are doing here from this point, what we are expecting. So position and label both are the independent variables, of course. So from the position label, I am choosing label as a independent variable. Okay, as a independent variable. So I'm choosing this one as an independent variable. Independent value. It is better idea to write an independent value. Or here, salary will be the your dependent. Salary as a dependent value. Okay, or variables we can say. Dependent variable is also known as a response variable, and independent variable is also known as the explanatory variable. So this is only naming convention and nothing else especially. And after this point, what I'm doing over here, see, I'm printing the x, I'm printing the y. So in the x, what is to be stored? The label values. Okay, so this is the labels, all the labels values. That was the independent variable. And salary is what? Salary is a y dependent variable. So I'm printing both values. I'm founding over here. This is the printing of the labels, that is a independent variable, and this is the printing of the salary, and which is what? Which is the dependent variable. Yes, tell me. After doing so, we are building the model. Okay, but before building the model, what is our responsibility? We need to filter the information in form of the training data and testing data. Here, according to your need, according to our problem, just let me execute this code once again in front of you. Then you will able to see the value. Now after this one, I'm just executing again. I'm printing again, and I am just printing all these value. Now, what is the next activity? Before building the model, our data set should be divided into a two different part. One is a training data, other one is a testing data. So here, previously, I have done the testing data as a 20%. So training data is 80%, and training data 80%, testing data is 20%. According to your demand, if you want to update, then please tell me what would be the size of the testing data I should use. And now let me know what is the size of the total data. So you can see, you can observe over here, there are total, we have the 10 data. From these 10 data, we need to divide our information to the 80 or 20. So testing data will be the 20%. But if you wish, then you want to update, then we can update in front of you. Then definitely you will see the some difference. Now tell me, what should I do? What would be the size of the testing data I should opt here? Yes, please tell me. Same thing, same code we have over here, the sklearn model selection training test bit function or method we will use. Just I need to know the size of the testing data from your side. Just please tell me which size I should use. Yes, friend, please tell me. Can you tell me the size of the testing data so I can opt properly? Yes, friend, please tell me. Can anyone tell me the size of the data set so I can opt properly?
No idea. No idea, sir.
So can you repeat once again? Yes, please. Can you repeat once again so I can update the my code according to your need?
Yes, sir.
Yes, please tell me. Can you tell me the size of the testing data so I can update this code? I have already taken the 20%, but if you want to update more, then I can take. So please tell me.
0.5, 50%, 50%.
30%. So 0.3. Okay.
Okay,
Do you
sir.
want do you want 35? Do you want 36? Do you want to 39? Then I can take. 30% is sufficient.
Yes, sir. 30.
Okay, so from this point we can understand total size we have the 100. So I'm just using 70 30. 30% will be testing data and 70% will be the training data. And after running this code, we can execute and we can see now extrain xtext. So this is information which
सर सर
describes. Yes, please tell me.
सर
Yes,
अगर
please
हम
tell me.
लोग दोनों इक्वल परसेंटेज पे ले लेंगे ट्रेनिंग और टेस्टिंग डेटा तो फिर एरर परसेंटेज बढ़ जाएगा ना उसमें
नहीं नहीं, देखिए मैं आपको बताता हूँ. We have the data, and error is not see, error is what? Error is the define the difference between the actual output or predicting output. So our model is fit to the specific line. Okay, so we have the line. Our model is fit to the line, but the actual point which is described via the data point only, but prediction based on the line. So difference between the, we have the huge volume, so we can say we are increasing the error rate. So to avoid such thing, we need to go through the polynomial regression. Here, what is the training data, what is data size, that is not as a part of the increasing the error or decreasing the error. Here we need to define the model, we need to design the model, we need to build the model. And to build the model, training data is required, because without training data, how you can build the model? Just like example, without training, how you can become the part of an employee of a company? So you want to become an employee of such company, then training is required. So training is required. Without training, how you can become the part of a company? It is my point. So training data and testing data size is not a important issue to increase or decrease the error. Okay. So if you want to update this one, then I can update. So now tell
Yes,
me.
sir.
Okay. So now after 30% getting the test size, I found over there. Now this is a value, that is I'm getting the label. So this label is what? This label is the my independent value. I got it, and respectively I got the y value. Those are the salary of the part. 695, these are the value which represent the testing data only. Okay, so randomly randomly is chosen by the system, so I got this all this value. Okay, if I update or I rerun, then I will see, I can see. Okay, if you want to again rerun, then you can update, no problem, you can see. But see, we are getting the randomly, so it is not in our hand. We are selecting the information, or we are getting the information in the randomness. And after selecting or after deciding the training data, now what is our responsibility? We need to fit the model. So first we will fit the model. So we will fit the model according to the linear regression. And same thing we will do like over here. If you're fitting the model, now this is my point. If you're fitting the model according to the linear regression, then our model will look like this one. Now the image is visible to all. Just let me know the graph is visible to all right now. Then I will tell you more detail about here. Just tell me. The image is visible to all right now.
Yes, sir.
So what is the point you can note down over here, my dear students, please. The data points are scattered over into the red color, but line is drawn by the blue color. And now you can see the line is just expecting that could be the prediction. Your model line point is showing the prediction, but most of the dotted are far from the line points. Okay, more of the data points with the actual data point which is dotted by the red color are far from the line points. So that define the we can say we can have the many we can have the huge amount of error, because if you are calculating such error, definitely we will get the error into the large volume. And this is a big problem we are dealing into the linear regression. So at the time the multi-polynomial or multinomial regression is required. So polynomial is important part. So here polynomial regression will help the our problem. So now see how we can see. So we are fitting the model according to the linear regression. So we fit the model over here, and we will display each and everything over here. So let me rerun once again for your more clarification. So I have rerun, so we got the same answer. So linear regression. Now it's our time to fit the model according to the polynomial. Okay, so this is the point. Okay, so here what he observed here, we have observed here the model is fit to the linear regression. Okay, but what is the next, what is our responsibility? Model should be fit to the polynomial. Okay, for doing so, what we need to do, you can read out over here the regression to the data set. Okay, is it visible to all right now? Fitting the polynomial regression to the data set. So we are fitting the word model followed by the training data set fit to the polynomial regression based. Okay, now is it clear to all right now? Yes, please tell me, is it clear?
Yes, sir. Yes, sir.
Okay, good. So after getting this point, so what we need to do, we need to import a library, that is a that we need to import a class from the SQL library, that is the pre-processing. And within this pre-processing library we have the polynomial feature class. From this class, what we need to do, we need to use, so we will use this class to to define the polynomial. Okay, to define the polynomial of the, I can write like this one here, so you can understand. You use this class to define the polynomial of the independent variables. Okay, independent variables or variables. Right now we have only one, so we have the independent variable. So how we can define? We will use the poly regression. This is the user defined variable. So you can take any XYZ. So I'm taking the poly underscore reg variable. So this is the name of the variable. And from the polynomial feature based class, I need to pass a degree. So you can pass any degree of 2, 3, 4, 5. So I'm taking the standard value of the degree, that is a 5. So you can define the any degree. What the degree you want to use, you can define the n number of degrees, doesn't mean. So I'm choosing only the 5. If you want to update 2, 3, then you can update. If you want to update something, then you can update. So why I'm taking the 5? Because 5 is a very that would be define the my polynomial values very close to the all the data points. So that is the reason I am taking the 5 degree. You can update this value, but definitely your data point may be little bit far from your actual line. So this is my reason I'm taking only the degree 5. You can update according to your need. And what I need to do from this point, after defining the feature or after defining the degree of the polynomial, then I need to fit the model. And the here we will not use the fit model, we will use the fit underscore transform method to fit the model followed by the x is what independent variable. So here what we are doing here, fitting the model, fitting the model followed by the independent variable. Okay. So now with this point, linear regression, okay, linear regression. So my model is fit. My model is fit to the independent variable. Now, what I need to do? So we got the new independent variable which is following by the polynomial based point. And now let me complete this point. After fitting the model, so what I'm getting after fitting the model independent variable, and just let me write here, which supports the polynomial polynomial degree. Okay, so it's now, so what I will get, I will get the new independent variable. So what I will get will be, we get new uh, independent values in terms of degree. Okay, so what is the value we got? We got the x poly. So with the help of the x poly and dependent variable, we will fit the our model followed by the linear regression. So that our line will fit to the on the that data point. After doing so, if we use the that model, we will print or we will display that model. So definitely, what would be the our output? So let us print over here. Now after executing this code, now the our line will fit to the all the data points. This is the reason. So that's why you can say here we are not using the, here we are not passing the any straight line equation, because linear model support the linear equations. But here I'm just designing the my model followed by the polynomial. So here my model is to be designed by the polynomial base. So here I'm passing the degree 5. Suppose I'm changing different degrees, so definitely my model may be not close to the my data point. So this is the reason. So I'm taking the standard value, that you can take the 5 or 6, whatever you want to use, you can use. So this is the reasons. Now tell me, is it clear to all right now? Is it clear?
Yes,
How
sir.
we are,
Yes.
how we are getting, why it is required? So after this point, what we need to do? We are predicting something. Okay, what we are predicting something? Just let me clear to all. Here we have the something. So just let me, yes. Okay. So from this point, I need to see. I need to predict something value followed by the, I need to predict something value followed by the linear regression. So if I'm using the this variable which is taken by me, so lin underscore regression, this is my linear regression object of the by default linear regression model. So that is a my this image. If I'm using this model to produce some values over here, so what value I will get it? Okay, let me remove this line here because this is the no. So I'm using some 5.5. It means I'm talking about the label. So I'm predicting the something. What would be the my expected salary at my position 5.5. So I'm just putting anything. So I will get the this result. Okay, I'm getting this result. But according to the polynomial regression, and that is model my fit to the close to the all the data point or on the data points. Now, if I'm doing so, if I'm doing so, so what is the value I'm getting over here? That is a this point. So this is a my point. And now say what is the value or what is the salary of the employee who has a level 5. The employee, the position if I belong to the country manager and the level is 5 and salary is a 1,10,000. If I'm using linear model, then what I'm observing, what I'm getting the 22 lakh 49,000, but it should be the close to the 1 lakh. So it provide the linear regression provide the big gap in terms of the prediction. So why? Because linear regression providing the huge amount of errors, and due to that error, I am getting the big difference between the my actual thing or my prediction. So now see, we have the approx 1,30,000 difference. But if I'm using the polynomial regression, and that defines the my that defines the very close to the my answer. What was the my expected salary? That should be the 1.32. So okay, it's okay, very close to the 5. So we can expect. Okay, this is my reason. But in the prediction, in the linear regression, we can use a predict method. Okay, thing see, whenever prediction we are doing from the linear regression, so we are getting the huge differences and due to the error. Okay, so just let me write over here why we are getting the error. So we will get the big difference uh, between our prediction predictions predicted salary. Actually, I just need to write predicted salary because of use errors, because we have the huge amount of the errors. So just let me know huge amount of the errors. So write the appropriate terms, use amount of errors. But here we are close to. Here we are close to because we are using the or we are fitting the model close to our data point. It is just like simple example. Now see, a student is sitting in a room, and if I need to distribute the copy, if a student is close to me, then definitely I need to cover some distances. And if covering the distances, it will take some time. And this time is what? This is the distance is what? This is distance defines the error. So I need to take so much time. So if I'm taking much time, so I'm using the unnecessary. I'm just taking sources. But if a student is close to me, then what I need to cover only the minimum distance. So error should be minimized. This is the my intention. Okay, so this is the my intention. So this is what about the this is the about the polynomial regression. Okay, so this is the polynomial regression. Yes, student, now tell me, this was my point where I just disconnected due to the internet connectivity, but right now I'm back. So just I need to ask the question, do you have any doubt right now in today's class? Do you have any doubt from the in this point, multiple linear regression and polynomial regression? Yes, please tell me. Yes, student, tell me, do you have any doubt?
No, sir.
No,
So
sir.
okay, good. So see, only the few students are connected right now, 30 students. So just let me know the point. Is practically are you getting something or theoretically is necessary part? Just let me know.
Technically, sir.
Practically I told you three different examples. One is linear regression, and we are seeing the two different model multiple linear regression or multiple regression, and another one is a polynomial. Just now tell me, is it clear to all right now? The practically is required part or theoretically is okay? See, I just need the
Sir,
output from your side. So practically, did you got something from the today's class as well as yesterday's class?
Yes, sir.
What we are doing. So don't worry about that part. I will share the code as well. So uh, don't worry about this part. Okay. So I will share the code as well in for the PDF format only. So if from the you can download the PDF and you can easily copy paste and you can run the code. And I have already shared the dataset over here. So I will also share the dataset on the Google Classroom. So you can use a such dataset to see the our result. What would be the expected values? Okay, so just tell me right now, we should use the theory and practical simultaneously, as we have done into our 5 classes. Should we use like this approach? Okay, now tell me,
Yes.
should we like this approach? First one theory and then
Yes,
practical.
sir. Yes, sir.
Okay, so don't. Okay, good. So I will discuss each and everything like this pattern. First one is theory and then practical, theory and practical. So practical is required, and I will tell the practical more and more detail into a specific manner. So don't worry about that part. So we have seen the practical part as well, and we have seen the theoretical part. So now let me just simple give me some idea. Except to the only logistic regression, is everything is clear to all about the regression and how regression model will work and how model is working, followed by the 3 different kind of the approaches of the regression. Is it clear to all about the regression right now? See, be genuine and please be speak something over here. Be genuine.
Yes, sir.
ईमानदारी से
Yes.
ईमानदारी से बताना कि ये प्रैक्टिक 3 मॉडल समझ में आए कि नहीं आए.
आगे सर.
सर आगे.
तो पर एग्जाम में मिस्टेक्स नहीं होनी चाहिए. एग्जाम में अगर मैं क्वेश्चन घुमा भरा के कैसे पूछूं तो आई एम एक्सपेक्टिंग द बेटर रिजल्ट. ओके, मुझे ये नहीं है कि क्वेश्चन सर ये आपने ऐसे पूछ लिया वैसे पूछ लिया. So now you all are ready for the exercise. If I give some exercise practical, then you will able to solve the problem. So I have seen some exercise. I will distribute the exercise, and you all have to write the code in your way. But you can use all these codes. Or I will share these codes. You will use all these code to write the something into different way. So my question will be in different way, but you have to use all these code. Okay. So with this all these words, so just let me down to your attendance last time because new 7 students are still connected with me more. 37, 30 plus 7. So I'm downloading attendance. Give me 1 second. I'm downloading attendance right now. After downloading attendance, we have okay, now it's downloaded. Okay, it's no problem. Okay, now tell me any issue from the today's class, the multiple linear regression and polynomial regression. Please tell me any doubt.
No,
No,
sir.
sir.
So theoretically, is it required to share the theoretical notes as well, or is it okay? You can understand, you can write.
So please share the
Yeah,
Please
please
theoretical.
share
share
the theoretical.
both the notes.
So now tell me, what is the theory you require? Polynomial regression, you can understand. Polynomial regression, I have shown through the images. Now, what is the thing you need? Just I need the answer. This is my point. What is the theory you are expecting? So I can see, I can take care of all this kind of theory. Now just let me know what kind of theory you are expecting. Just tell me now. Just tell me what kind of theory you are expecting. The working is important. So I have shown the working through the diagram, through the images, through the practical. So now tell me what kind of theory you are expecting. Just tell me. Tell me. Just it's 9:15. Sorry, it's 11:15.
So we can read about theories like how the linear regression
sir.
is implemented, like the in scikit-learn it is implemented using the ordinary least square method. We also have like regen lasso regression, some theory on that. So it would be better in those cases, only in those cases.
See. Okay, I will share some information. Don't worry about that. But now question is that regression also having the various flavor, just like the stepwise regression. So there are so many flavors. So we will discuss only those regression which are the part of the our curriculum first, and other than we will discuss later on. We will discuss, no problem. But we need to cover only those regression which are the part of the syllabus. So after understanding the linear regression, as I shown you the linear regression through the PPT. So PPT I will share. But after understanding the linear regression, now tell me, Vijay, now tell me, is it required to discuss? Is it required to share the notes about the multiple regression? Because only the what we are doing, we are increasing the more than one independent variable, and that you can write, and you know the differences. After understanding this point, you can understand. You can try the difference. So what is the things required? So what is the expecting you are looking for? If I tell you new kind of regression that is not possible, or that is not support, or not based on the different our previous regression, then I will share. This is my point. In the polynomial regression, I have put it those contain which differentiate between the linear to non-linearity. So you can understand now. You can say, so what is the difference between non-linear non-linear linear regression? You can understand. So by the image you can understand. So that's why I'm asking. So now, Injustice, now tell me.
Yes, sir.
Now tell me. Now tell me. So, is it required to share the notes?
Sir, actually, it's not required, but it would be better if we had the notes, something like that. Not,
No.
it's not like mandatory. Like it's just to quench our curiosity, something like that.
Okay. So I will do one thing for your removing your curiosity. I will share the notes that define the difference between the linear, non-linear regression, linear regression example. Okay, linear regression example, non-linear example. Okay, so this kind of notes I will share. Okay.
Okay, sir. Yeah. Thank you,
So
sir.
definitely you can understand, you can differentiate for the examination purpose. So my notes will help you to into the examination whenever looking for something examination purpose. You will try to something from the regression, then you can understand. But here my
Yes.
aim to that after understanding the basic things. So now is it clear to all about these two different programs? Is it clear to all right now? Just I need the real answer actually.
Yes, sir, it's clear.
See,
Yes, sir. Yes.
yes, yes. See, what we have see, what we have done. We have just implemented new things followed by the previous example, that is the linear regression. So we have done some amendment only. See, you have seen observed so many things. I have just little bit. I did the little bit amendment only. I did not write entire program. I did the little bit amendment followed by the two different kind of a data set. If I'm using same data set, then you will be so you are using same data set. Can you take the another data set? That's why I have chosen the three different data sets. And see, I am not using the standard data set. I'm using a simple data set. You can use your own data set. You can define your own data set. You can use your existing data set, just like medical imaging data set. You can use any kind of a standard data set, and this code will help you to understand how we are learning. This is my motive only. So don't worry about that part. I will share some notes. I will share something regarding the regression more and more in detail way, and advantage, disadvantage. Okay, difference between the all three different kinds of regressions. Okay, but so many regressions variety we have, but we will discuss the step by regression. But that is not part of the syllabus right now, so we will need to discuss. If time permits and if it's required, then I will discuss, then I will share. So we will start from the very beginning. We will start from the scratch manner. We will see step by step. Okay, we will not jump directly. See, understand the step by regression. We have the different kind of more and more regression, so it is not required. One more regression is required so far, that is a logistic regression. So I will discuss logistic regression whenever it requires, that is a classification. So when we will discuss the classification concept, then I will discuss practical session through the classification by the logical regression. So definitely it's required. And notes, don't worry about the notes as according to what required. So I will share the notes. Don't worry about that part. But please be genuine whenever you feel any doubt into the programming part. Please, you can ask me anytime. But you have to go along with me to learn some things, just like the pre-processing. The pre-processing class I have to use, and that is only the class which contain the polynomial feature methods. So that is not in my hand. We have to use it, is a need. So we have to keep in mind something. some functions are already available, so we have to just like printf function. So we need to print something, so we have to use a printf function. Why? Because it is required. So we can't write the print or we can't write the other function name. We have to use the same function name, and that is for printing purpose. Same thing, if you want to use the polynomial feature, then you have to use a pre-processing class. It is required. So few things you have to keep in mind.